right, so part 2, let's do this. So what's the best way to do this? So we already went through, I gave you the factoring flowchart, not factoring flowchart, but solving a polynomial flowchart to help you kind of get an idea of which steps you should go through. We talked about the list of all the things that you should keep in mind, like the remainder root theorem, etc., fundamental theorem of algebra. Okay, so now let's actually, what would this look like? So you get this large problem to start with. It's a 4th degree. It has 1, 2, 3, 4, 5 terms. So you're looking at this and you're like, oh, okay, so it's x to the 4th. Well, I know I need 4 roots. That's somewhere to start. Can I factor it? No. There's too many terms. If you have more than 4 terms, you can't factor it. So it can't be factored by grouping. Nothing I can do. Okay, so no. Rational roots theorem, yes! So P over Q, I've got 36. Doesn't really matter, 36, negative 36. You just need the constant. It's kind of irrelevant if it's positive or negative. Over 1. Okay, so I come up with my list of possible rational roots. Here they are, nice long list. Okay, so I have this long list. Calculator assistance, yes please. Here's my picture of what happened in the calculator. So then I am starting to think, wheels in my head turning. I only see 2 roots in the picture. These little green lines are the graph. But I have 4 roots. So wheels turning, thinking, must be 2 imaginary roots. We'll get back to that. Okay, so negative 1 and 4. So synthetic division. Negative 1 or 4, doesn't matter. Start with either one. I started with 4. Did my synthetic division. I'm down to a cubic. Could this be factored? I don't know, maybe. It has 4 terms. I might be able to factor by grouping. But I think let's just keep dividing. Plug in negative 1. Now I'm down to only 3 terms because I know that this is my remainder. Success. I'm down to a quadratic. Thank God. Alright, so I go back. Here's the quadratic I'm left with. I was left with 1, 0, and 9. So there's my constant. There's my first term, there's my 2nd degree term, so I'm left with x squared plus 9. That's not factorable, what am I going to do? Wait for it. Quadratic formula? You could do that, but there's no b term, so that seems like a lot of work. You know, I got to do negative b plus or minus square root. That's like so many things to write down. Why would I want to do all that? Square root property? Yes. So much easier. Alright, so x squared equals negative 9. I just subtracted the 9. Take the square root of both sides, and I get x equals plus or minus 3i. So remember when I was thinking wheels turning, must be 2 imaginary roots? I know that imaginary roots must come together, so therefore I find out I have 2 imaginary roots, plus or minus 3i, that's 2. Plus, minus, negative 1, and 4. That's my final answer to my problem. That was x to the 4th. Okay, it's a lot to handle, right? Let's try one more. Next problem. Here we go. We got x cubed minus 2x squared minus 2x minus 3. I'm starting with a cubic. So, how many roots? 3. Can I factor it? 4 terms, maybe by grouping. If I put that together and take out an x squared, I'd have x minus 1. That's never going to turn into x minus 1. Okay, nope. Not going to be able to factor. No. Rational roots theorem? Yes. 3 over 1. So I have plus or minus 1 and 3. That makes it pretty easy. I don't have too many. Calculator assistance? Obviously. That's what it looks like. I can see it goes through at 3. Synthetic division? Yes, ma'am. Here's the 3. I've got 1. Alright. Am I down to a quadratic? Why, yes I am. I have 3 terms. X squared plus x plus 1. That's the point. I want to be down to a quadratic. So I have found 1 root. One of them is 3. But how many do I have? 3. The other 2 must be imaginary. So I'm down to this. Whoa. death by a dry ice board, that would not be good. All right, let's put this back up. I'm okay, don't worry. All right, x squared plus x plus 1. I already know that cannot be factored because I just looked at the picture and there's no other rational answers. So I am not even going to try to factor it, but if you tried it, it's not possible. Okay, so I have my final answer down here. It's 3 and then 2 imaginary roots. So to get them, quadratic formula. Got a lot of 1s here. So I have -1 plus or minus 1 minus 4 is going to be -3 over 2. That's going to be -1 plus or minus I root 3 over 2. So my other roots are -1/2 plus or minus I root 3, or you could say root 3i. So there is my final answer. It was x to the third. I had 3 solutions. I have 1 real and I had 2 imaginary. So I hope this video helps. I hope it's cleared up a little bit of confusion. If not, see me for more help.